All right, guys. Good afternoon. Okay, so our job today is to remind ourselves quickly. We're going to try to divide this whole session into two. Paper one will do two sessions, and paper two sessions like that. Okay, just to make sure that everybody's on board. I hope we'll be able to find the time to get everyone ready. Okay, here we're just going to quickly discuss everything that has to do with waves in this session. If you remember, there are two types of waves. Do you remember them? There are two types of waves. We remember. So please, some of the things I'm going to make reference and some I'm going to... first, before we even go there, what are the definitions you and I need to know? Let's make a list of the definitions on waves. Number one is to remember what a pulse is. What a pulse is? Pulse is a disturbance, a single disturbance. Okay, a pulse is a single disturbance. Then we can then pulse is a single disturbance. Anybody remember the definition of a wave? Definition of a wave? I don't remember anything at all. What we spoke about, you must have done it at school, where we spoke about. Anybody wants to define what a wave is? When we talk about a pulse is a single disturbance. But when we talk about a wave, we talk about a series of pulses. Is that okay? Many pulses, then we talk about a wave. So we talk about a series of pulses. Go and check the definitions again and master them. There are two types of wave, if you remember. What are they? Longitudinal waves and transverse waves. Be able to remember also what the definitions are. Longitudinal waves, we talk about particles are parallel to the direction of the wave. Parallel to the direction. About transverse, we say the particles are perpendicular. Particles are perpendicular, that is 90 degrees. Direction of the wave. Direction of the wave. All of this we did in term one. Okay. And the way I quickly remember some of these things, I'll tell you. When I think of transverse, what's the spelling of transverse? It's a T. All right. And to write a T, check. This is what goes on in my head. Angle here. That's where the word perpendicular comes from. Perpendicular. Let's see if you remember a few things before we look at questions. If I draw a wave, can we label the parts? Can we label the parts of a wave? But we said we have longitudinal and we have what? Transverse. For example, water waves is a transverse wave. I put a paper in water. What happens? The paper goes up and down. Example here, water waves. Example of longitudinal is sound waves. And after drawing, we just get into questions. The questions, I have a wave here. I have that as a wave. Part A, I'm going to label that part B. Highest distance, let's call it C and B. A and E. I'm going to call this G, call this H. There's a relationship between G. What do you remember here? What do you remember? Tell me what you remember. All right, Linda. A, the trough, B, the crest. Okay, do you agree? What do you remember with this topic? No, with this. Mm, okay. The highest point in the graph is called the crest. Linda, you have mixed the two. Highest part is called the crest. Called the trough. What is C called? The amplitude. You got that one right? What is the distance between A and E? That's called this the wavelength. There's a textbook here. All right. Now, if you look at G and H, we would say G and H are in phase. That's the language. G and H. Those are the languages that we would use. Let's just answer a question quickly. G and H, they are in phase. Let's answer a question and see what you would be able to tell me. All right, here's a question. No, this is mechanical energy. Oh, gosh, no, this is not mechanical energy. All right, yeah, this is waves. Yes, guys, I still need to look at mechanical energy with you. All right, this is waves. Okay, thank you. Yeah, you got it. G and H are pointing waves in phase. Okay, guys, the figure below shows transverse wave motion. The period. Now, that's one thing we must know again. What is the definition of a period? What is the definition of a period? What is the definition of a period? Remember? No, it has to do with time, but not the time it takes for the graph. Okay, please write this definition down. Period is the time it takes for a complete wave. Period is the time it takes for a complete wave. Time it takes for a complete wave pass through a point. Time it takes for a complete wave to pass through a point. Now we are told that time is what? 0,2 seconds. How would you answer the first question? Calculate the frequency of the wave. Always a formula page. I'm trying to get. All right? How do you calculate frequency? Linda, what formula are we using? Kian, talk to me. Yes. Yeah, we have period. All right. I'll give you some. Frequency is 1 over t. So 1. Frequency is 1 over t. All right, everybody. Our t, which is 0,2. Please quickly calculate for me. Period is 1 over t. Get me your answer and get me the correct unit as well. All right, so we say 1 over what? And what? 5 hertz. Done there. Number 2, calculate the speed of the wave. Wave. If the I'll give you 2 minutes to try to remember. There are a few formulas that you should remember. Speed, V, F lambda. So those are 2 formulas that you should remember. Answers with me? Oh, you guys have 15 already. Let's get that 15. As per second. Answer 15. The period of the wave. Okay, please let's check something. Period of the wave. And we said period is the time it takes one complete what? Wave. Let's measure one complete wave. Where is our complete wave if we start from? That is complete. There's a complete wave. Okay. Here, this would be a complete. But we are measuring from this point now. Here, that is a. What does that mean? It means distance d is actually how many waves? Means the wavelength of this wave. The d. We have two waves there. We were told that that's 3 meters. So what is the what formula can we use? We have our wave 5 times 1,5. Got it wrong. The examiner wanted to trick you, and they got you. I don't know if it makes sense. Let me know, Kian and Linda. A mistake there? Awesome. Guys, are we okay there? So you need to. All right? Can we answer this quickly? Write 2 points that are in phase. All right? Are we done? That are in phase. A and D are in phase. Notice at A. Well done, Linda. If you notice at A, this where is it going up again? Exactly like this. Down. Now it's going up again at the same point. A and what? D are in phase. Right? What is the amplitude of the wave? Can we define maximum displacement from what? Rest. What's the maximum displacement? All of this length is what? 30. We are looking for the maximum from rest, from here to here. Our amplitude, A, is 15. Waves, that's how we answer waves. We need to just remember those little points and get wavelength is for one complete wave. Remember your definitions will be good. Coming back to memory right now. Back in term 1. Let me give you 5 minutes. Give me answers here. Whatever you remember. Whatever you remember. It's 5 marks. Whatever you can remember, put something down. Answer. Your scope says electro. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 All right, Kian, I got your answers. Let me check what your answers. Guys? Working. You done? Oh, okay. Let's mark then. What is a pulse? Single disturbance in a medium. All right. What is the name given to the type of interference that occurs at R? Destructive interference. Why destructive? Because one is the crest and the other one is the trough. Crest and crest, it is constructive. If trough and trough, constructive. One is going up and one is going down. Is that okay? So this then becomes a destructive what? Interference. Draw the resultant of two pulses at R. Indicate the resultant amplitude. Okay, did you draw that? Up is higher, is 1, when we say destructive, because this one here is actually a positive one, and this one is what? A negative. So we would be having something like that, but the height here would be what? 1, no, sorry, what? 6 meters. It has reduced. That's why we call it what? That things are coming back gradually. You know? Oh, did we do this? Okay, good. Let's look at this one. Once you are done, please let me know. You must go back. That's that. Okay. Are we done? Are we done? All right. Write down the labels A, B, C. What are you telling me about A? Rarefactions. Lovely. B. Compression. C. Ah, you guys are the best. Now you remember. This is what? Rarefactions. What is B? Compression. And what is C? Wavelength. Does this type of wave require a medium to propagate? Write down yes or no. What type of wave is this? Let's. Huh? It's a longitudinal wave. All right. So, does it need a medium? Give me an example of a longitudinal wave. Sound. Lovely. So, let's think about it. Do you think sound can travel where there's no air? Yes. The answer is yes. Yeah, we're trying to get to the answer now. Okay, wait, check something. Um, okay, let's look at this. We're discussing. Um, does this medium require a medium to travel? Yes or no? Now, are you aware that sound travels faster in water than in air? Tell you why. Sound travels based on energy. And what happens is one particle will transfer the energy to the other. Then, like that. And that's why sound will travel faster in a solid than in liquid, faster in liquid than in air. In a solid, the particles are close together. So energy is transferred. In a liquid, particles are a bit far. It takes time for energy to transfer. In a gas, particles are very far. It takes extra time. The speed of light is actually times 10 to the power 8. All right? But as you get into water and into other things, it starts changing. Is that okay? So our answer should be what? Yes, it needs a medium. Right. Our answer is yes, a medium is required. Okay, let's check quickly. Let's answer this one. Think about it. I'll give you 2 minutes. Think about it. All right. Which of the sound waves has a higher pitch? A. Are you sure? What's the reason? Have a higher frequency though. Frequency is the number of waves. Let's see. How many waves? A. 1.5. In B. 1, 2, right? And 2.5. Okay. So in A, we have what? 1.5. In B, have what? 2.5. There are two things the examiner is asking for here. They're asking for pitch and loudness. One with a higher frequency. Frequency controls what? Amplitude controls what? That's where our challenge is now. Frequency controls a particular thing. Then amplitude also controls. So it's either pitch or loudness, and we need to hit it right. Pitch or loudness, we need to hit it right. Frequency is okay. Let's see, Linda, what do you say? What do you say? Frequency is? Frequency affects the pitch. Linda, talk to me quickly. We're waiting on you now so that we can move on. Where did you get 6 from? All right. Okay, Linda is going your way, guys. That frequency affects what? Pitch. Okay. So don't let's forget. Frequency affects what? Pitch. And amplitude affects what? Loudness. So can we re-answer these questions? Which of the sound waves has a higher pitch? It has to be B. Why? Because of a higher what? Frequency. One is so B because of higher frequency. Which sound is louder? A. Why? Because of a higher what? Amplitude. All right, beautiful. So please take note. Loudness. Frequency pitch. Amplitude is loud. Okay, 12 marks. I'll give you, I want you to answer this whole thing. All right, 10 minutes. I'll help you with the one formula that you need to know. Formula that you need to know, which is E. Okay, quickly, let's walk. Linda, are you done? Oh, yeah. Thank you. You've given me your answers. Let's check. Electromagnetic radiation has a wave particle duality. What does this mean? What does it mean? What do you think it means? Let me see what Linda is saying. Particle can behave like both wave. Okay, you used the wrong word. Wave can behave, electromagnetic radiation can behave as a wave, can behave as a particle. Duality means two. Saying that electromagnetic radiations can act as a wave and can act as a particle. Arrange the following types. Okay, let me allow you to finish. Arrange the following in terms of decrease in wavelength. So we start from the highest wavelength to the lowest. One has the longest wavelength. Infrared. Infrared. Light. Light. Then we move to what? X-ray. And we move to what? Gamma rays. Why is this so? The energy of this is very low. Low energy. While this one has a very what? High energy. That's why you don't take X-rays every day saying energy is too high. And for it to have high energy, it must have low what? One with the shortest wavelength has the highest energy because E is directly proportional. Can you see this? Directly, the longer the wavelength, the smaller the energy. Let's write that. Let's write this down. This is very key. The longer the wavelength, smaller the energy. Energy of the photon. What is a photon now? That's the question. What is a photon? What did you do? Eh? Ever. What did you define it as? Huh? You guys have, at least I'm glad you have, it's there, but you're just using. Photon is simply a packet of energy. Packet of energy. Photon is a packet of energy. Okay. Huh. An 6 marks, 6 free marks here. An electromagnetic wave has a wavelength of that. What's our wavelength? 2,5. Wavelength is 2,5 times 10 to the power negative what? Right? What are we looking for? Amount of energy. We are check the formulas that I gave you. How would you use the first or the second one? What do we have? E equals negative 34 times 8 over what is wavelength? 2,5 times 10 to the power negative 9. 7, 596. 96. Okay. power negative 34 times 3 power 8 over 2.5 times 10 to the power negative 9. 7,956, which gives, oh, you said 59. That's what was confusing me. Oh, okay. 7, I was hearing 59. All right, so this is two decimal places. It's going to be 7,96 times 10 to the power negative what? 17. 7,96. What's the unit? Joules. 6 beautiful marks there. All right. Uh, but anyway, I don't know if what we did here made sense to you. They're going to ask you on waves. Yes. Section is on waves. It comes with a formula page. A formula page. That is it on waves. Let me quickly do mechanical energy with the last topic, mechanical energy. Yes. All right, Miriam, how are you? Have you done mechanical energy as well? Yeah, have you done mechanical energy? Guys, just a little. Just give me a moment.